Hey there, 8th graders, and welcome to today's Explainer. We're absolutely thrilled to have you here. Today, we're going to be unlocking a mathematical concept that literally changes how you view data. We're talking about comparing and ordering numbers using scientific notation. Now, I know it might sound like just another routine math topic, but I promise you, by the end of this, you're going to see massive numbers and honestly, the whole world around you in a completely new light. So, let's get right into it. To start us off, I want to anchor our lesson in a really profound piece of wisdom. It says, "Do not judge by appearances, but judge with right judgment." This actually comes from John 7:24. Now you might be wondering, why on earth are we starting a math explainer with a spiritual quote about judgment? Well, it's because this spiritual truth applies perfectly to mathematics. In life, we're constantly tempted to just look at the surface of a situation, right? We make these snap assumptions based on what we see right away. But true wisdom, it requires us to look way deeper, to see past the surface, and use careful reasoning. And math is exactly the same way. Numbers can wear disguises. They can look one way at first glance, but their true value is only revealed when we apply right judgment. Okay, let's dive into this. Section 1. Judging by appearances. So, when we're dealing with standard numbers, 100 is clearly bigger than 10, for sure. But in scientific notation, our visual cues can totally lead us astray. Let's put this to the test, shall we? On one side, we have 7.2 times 10 to the power of 3. On the other, 3.1 times 10 to the power of 5. I'm going to pause for a second. Which of these do you think is the bigger number? Your eye naturally wants to gravitate to that 7.2, doesn't it? Because, 7 is a whole lot bigger than 3. But if you guess 3.1 times 10 to the 5th, you are absolutely correct. The exponent is what tells the real story here. We'll get into exactly how that works in just a second, but this just proves the point. You simply cannot judge a number by its front-end appearance. And this brilliantly illustrates why mastering this concept is just so incredibly important. Why does this matter outside the classroom? Well, looking past appearances to find the true magnitude of a number is absolutely crucial for so many fields. Take data science. You're handling these massive data sets where scientific notation is literally the only way to make sense of the information. In engineering, a miscalculation of scale, just because a number seemed smaller, could be a complete disaster. Or think about astronomy. If we're comparing planetary sizes or measuring those mind-boggling distances between galaxies, you're dealing with numbers so huge they'd take up an entire page just to write out normally. Scientific notation compresses all that into something manageable, giving us the power to truly grasp the spectacular scale of the universe. Which brings us to Section 2, the secret of exponents. Let's unlock that magnitude. Okay, so how exactly do we conquer these disguised numbers? Remember, scientific notation isn't here to confuse you. It's an elegant tool designed to give you the power to easily compare numbers based on their true size. And the exponent? That is the secret key. Here are the step-by-step rules. Step 1. Always compare the exponents first. This is our mathematical way of applying right judgment. You look at the front decimal. Actually, scratch that. You completely ignore the decimal number at the front for a second and look straight at that little number floating at the top right of the 10. A number with a higher positive exponent is larger, period. But what if the exponent is negative? Well, for negative exponents, a less negative number is actually greater. So, for example, an exponent of -2 is greater than -4 just because it's closer to 0. Now, step 2. If and only if the exponents are exactly the same, then you look at those decimal parts to break the tie. Pretty straightforward, right? Let's see how this builds our practical skills. All right, Section 3, testing our right judgment. Let's get some practice in. Now, what's really interesting about this slide is how instantly we can solve what looks like a complicated math problem. Let's look at example 1. Which is greater, 2.5 times 10 to the 6th power or 4.1 times 10 to the 5th power? Think back to our rules. Step 1, look at the exponents. We've got a 6 and we've got a 5. Because 6 is greater than 5, that first number instantly wins. 2.5 times 10 to the 6th is greater. It does not matter one single bit that the decimal 4.1 is larger than 2.5. The exponent 6 means we're multiplying by 10 6 times. The magnitude is undeniably larger. Boom. Right judgment applied. Okay, let's try something kinda tricky. Ordering negative exponents. I want you to imagine this sequence like a timeline. We need to order these from least to greatest. 6.5 times 10 to the -4, 3.2 times 10 to the -2, and 2.1 times 10 to the -1. Again, stay laser focused on the exponents. -4, -2, -1. Remember that rule for negatives we talked about? The more negative the exponent is, the smaller the magnitude of the number. It's basically a tinier fraction. So -4 is our smallest exponent. That means 6.5 times 10 to the -4 goes first. Sequentially next is -2, so 3.2 times 10 to the -2 sits right in the middle. And finally, our least negative exponent is -1, which makes 2.1 times 10 to the -1 the greatest number in this whole shebang. Look at that. You just successfully ordered microscopic magnitudes. Let's lock this in with one final example. Compare 1.7 times 10 to the 8th power versus 1.6 times 10 to the 9th power. Once again, please don't let initial appearances fool you. The 1.7 is technically larger than the 1.6, and your brain might just want to scream that the first option is bigger. But right judgment tells us to immediately look at the exponents. We have an 8 versus a 9. That exponent 9 tells the true undeniable story here. 1.6 times 10 to the 9th is greater. It is an entire order of magnitude larger, literally 10 times bigger than the other number, regardless of what those front decimals are doing.
Moving right along to Section 4, Real-World Practice Skills. It's homework time.
Okay, this is your chance to really build those critical thinking muscles independently. Listening to me explain it is one thing, right? But doing it yourself, that's where the real magic happens. So here is homework part 1. Question 1. Which is greater, 3 times 10 to the 7th or 9 times 10 to the 6th? Question 2. Order from least to greatest. 1.2 times 10 to the -2, 2.5 times 10 to the -1, and 9.1 times 10 to the -3. I highly advise you just pause the explainer right here, grab a pencil, get some paper, and write these down. Take your time, apply the 2 steps we just learned, and trust the process. Do not let those front numbers distract you.
All right, and here is homework part 2. Question 3. True or false? 7.5 times 10 to the 3rd is greater than 6.9 times 10 to the 4th. Question 4. Compare 4.2 times 10 to the -5 and 5.0 times 10 to the -6. And finally, question 5. Explain how to compare 2 numbers written in scientific notation. I really want to reinforce that question number 5 is the ultimate test. If you can explain these rules clearly in your own words, it proves you haven't just memorized some quick math trick. You have fully, completely internalized this new right judgment.
And finally, Section 5, True Education and Morality.
As we wrap up our lesson today, I want to slow down our pacing just a little bit. We've been operating with a ton of high-energy math momentum, but let's take a second to look at the foundational concept of true education. So the crucial point of the Hero Smart Academy Godly Learners series is that intertwining education with biblical morality is just absolutely essential. Why? Because education without morality will hurt. Just think about it. What is the actual point of being incredibly smart, of being supposedly highly educated, of knowing exactly how to calculate vast planetary distances with scientific notation, if you're going to continue to make bad surface-level choices in your life that end up hurting yourself and others? Being brilliant in math means nothing if we don't also develop the character to make wise moral life choices. True education is about shaping your mind and your heart together.
I really want to leave you with this beautiful thought today. Romans 8:6-7 promises peace of mind to everyone who keeps their minds spiritual. When we engage with learning, whether we're talking about math, science, literature, whatever it is, through a lens of spiritual wisdom, we experience this really deep sense of peace. We aren't just memorizing dry facts, we're learning how to seek truth. We are practicing how to look past the deceptive appearances of the world and judge with right judgment. So my final question to you today is this. How do you plan to use your education, your sharp mind, and your spiritual mindset to look past appearances and make the right judgments in your life today? Thank you so much for hanging out and learning with me, and I'll catch you in the next explainer.